Hello everybody, my name's Stu, and today we're just going to do a quick tutorial on how to build a car. There's a couple things you're going to need before we start. First of all, you're going to need Garrysmod. So if you go to garrysmod.com, I'll add a link in the description so you can easily get it. There's plenty of information on how to install and how to maintain your Garrysmod add-ons folder. Second of all, you're going to need some tools that I highly recommend just for general building. So precision or easy precision, I think it's just changed to precision now. I'll add a link to all the add-ons you need. So what this does is it adds a whole lot of utility and tools, but what we really want out of this is the offset or snap distance, and it's just useful in general. Second of all, we're going to need the weight tool. I highly recommend this. You might not use it often, but when you do, it can come in handy. And last of all, you're going to need ball socket advanced. I think in Gmod 13 it was removed, so you might need an add-on again to get this back into the game. I'm aware that it was in previous versions of Garrysmod, but currently that's not the case. So I think that's about it for what we need. So what we're going to do here today is, I've already built this car before, and hopefully I can sort of show you what I've used to make this all. So let's get started. First of all, we're going to need a frame for the car. You can use whatever props you like, but this is just my personal preference. So these are just PHX props, which I'm pretty sure comes standard with Garrysmod 13. So first of all, we're just going to weld these the frame together. So just put that to there. And second of all, I'm just going to explain what these are. We're going to use these to mount the wheels on. So first of all, we need to make sure the weight is set properly. So as we can see, the wheels are set to a weight of 200, but these plates are set to 2. So they're going to sag and it's going to ruin the whole car. So we'll set these to about 300, I think is a good weight. You can use, like I said, any prop you want, but you have to make sure these plates are heavier than the wheels you're using. So we'll set all these to 300, and we're gonna put 2 at the back to hold the wheels, and they don't need to move. Although you can make them, you can access weld them onto the back, but just for this purpose, we're gonna simply weld them onto the back of the car, like so. And it's fairly important to keep them snapped to the same points, otherwise you can have a wheel that sticks out further and the car will eventually start turning left or right. And next of all, we're going to go to axis. So we'll axis the left plate, and we'll access the right plate. And finally, the steering plate, which is what we're going to use to control these other 2 axis wheel plates, so that when I rotate this, these 2 will rotate. So we want to make sure everything's aligned and not crooked, because this could potentially screw up the car. And we've just got a plate here to put wire on, so if we want to adjust the car, we have easy access. So first of all, we need to go to ball socket advanced, and there's 2 settings that we're going to need to use. First of all, we need to make sure that the steering plate cannot move all the way around, because otherwise you're going to have the wheels spinning and it's not going to look pretty. So the settings for these we want to set the X and Y minimums to minus 180, and the X and Y maximums to 180. But the Z minimum we want to set to minus 35, and the Z maximum to 35. So we'll go to the steering plate, to the frame, and see what this will do is now we cannot move the steering plate further than 35 degrees to the left and 35 degrees to the right. And you can adjust this to any number you want. I'd say up to about 50 degrees it starts to look a little bit weird, so keep it within 35 to 50 degrees. Second of all, we're going to want to set all of our X, Y, and Z minimum and maximums to 0. And what this will do, as I'll show you in a moment. So everything is at 0. So we're going to go from the steering plate to the left plate, the steering plate to the right plate, and both the left and right plates together. And so what this will do is when we rotate the steering plate, both the left and right wheel plates will move with it. Next of all, we want to make sure that we can control this, so it's not just flapping around wildly. So, steam. Go away. And go to wire. And we want to go to hydraulic. And you need to make sure that fixed is not ticked, otherwise this will not work. So this is where things can get complex, so I advise you just to take note of what you're doing here. So we want to go and add hydraulics to push this left and right. So you can probably get away with just adding 2, but we're going to add 4 just for stability. So we want to add a front left hydraulic, and we'll put this in the top left, and we're going to do a front right hydraulic, and we'll put it in the top right. And same with the back left and the back right. So bottom left, and bottom right. And we want to make sure that the distance between each of these ends and the frame is the same, so that all of our hydraulic lengths are the same. So it's about 21 at the moment, so that's pretty good. So now what you want to do is go to wire and numpad input. We're going to make sure toggle is not switched on, and we'll assign a key. So let's assign it to left arrow. And we want to set the value off to whatever our hydraulic input, the hydraulic length was. So that's 21. So off will be 21. And the value on will be roughly double of the off value. So we'll put it to 40. You can tweak this any way you want. Obviously, the higher the on value is, the more distance that these hydraulics want to move. And we want to create one for the right arrow, so we've got left and right inputs for steering. And see what the hydraulic does, it serves 2 purposes. The hydraulics give you the ability to steer, as well as resetting the steering column back to the center. It should roughly do it anyway. And that's important because if you let go of the left arrow, you want the wheels to go back to the center, and same with right. Okay, so let's pull out our wire tool, and we'll wire. This is the tricky bit. We need to make sure that we've placed the top left and top right and bottom left and bottom right hydraulics properly. So what we want to happen is the top right hydraulic and the bottom left hydraulic to extend, and what that'll do is turn the steering to the left. So the top right and the bottom left and the top left and the bottom right. So now when I hit the left and right mouse button, sorry, arrow keys, it'll turn this. And if you tweak the on values a bit higher, it'll push the hydraulics a little bit further. So that's our steering done. Oh, it's a bit misaligned, so yeah, that's a problem. We're not going to worry about that, but when you're welding things, you need to make sure that they're perfectly aligned, otherwise they'll be crooked, and you'll have a wheel sort of off in that direction, and it's a mess. Anyway, we won't worry about that. What we need to do next is add propulsion. So I'm going to use forces. They seem to work really well with this design. So we want to put one for forwards and one for backwards. And very important, we need to set the multiplier to 100. Any less and the car won't go forward very fast. And if you go crazy and add it to 1000, you're going to notice your car just disappears because it's too fast. Okay, so now we need to go back to precision. And this is where the precision comes in handy. The offset distance, or the snap distance, we'll set to 3. So it's going to... and we're going to weld, we don't want to axis. So we're going to weld our reversing forcer to there. And where'd the other one go? Here it is. And our forward forcer to the back. So this force is going to push forward, and this force, sorry about that. This force is going to push us backwards, so forward and reverse. And importantly, we need to see this laser. If we don't see the laser, we know that the forces contact, or it's pushing into something. And we want it to be pushing into this steering plate and nothing else. So when you're building stuff around this, if you're building, say, like a car frame, you want to make sure that nothing's going to interfere with any of this. So now what we need to do is add an input for forward and make sure our toggle is off. We'll put the value off to 0, so we don't want it to... So when we're not pressing forward, we don't want the car to move. And the multiplier is set to 100, so 100 multiplied by 300 is around about a good value to set. So that's our forward. We'll go down arrow. That's our reverse. And now we wire the forces. And you need to make sure you use force and not velocity. What velocity will do is I'll demonstrate with the reverse. Force tends to give the car acceleration, and velocity will propel the car at a set speed instantaneously. So it doesn't really work with the car. Maybe on a train or an airship or something is a bit more suitable, but we'll just do this for testing purposes. So let's test that our forces work. So we'll press up arrow, yep, so it works. We'll unfreeze all of that, so it's turning. Yep. Okay, so now we just need to add the wheels. So let's access these onto the plates. And again, I've misaligned this, so the wheel's going to be slightly skewed. But that shouldn't matter, you guys get the gist of it. We'll finish welding these. And that's about it. So now, if we use our arrow keys, we've got a working car. Now, see, this is what I was talking about with the force and velocity. Velocity will sort of jerk the car backwards, whereas force tends to push the car forward. Anyway, this has been Stuart giving you a quick car tutorial. If you have any comments or questions, just feel free to leave a comment. Thanks for watching.